Okay, so we're looking at chapter 4. So go ahead and read this. See if you can try it out. We're using this formula for height. So this is we're trying to find our height given some time t. Right? That's why it says f of t or h of t. Because it's saying the height is whatever the height, we're trying to find the height given the variable t. So in those parentheses, that's just, it's not h times t, it's representing that our variable is t. So we're trying to find h when our variable is t. And c is given. C is the height of where it falls from a height of c, so that's our starting height. Okay, so how long will it take a flower pot to reach the ground? What's the height of the ground? Right, if I hit on the ground is 0 feet high, and it falls from 64 feet high, so that'd be our c. So c is equal to 64. So we can enter that into our formula. Negative 16 t squared. Negative 16 is due to the force due to gravity. Feet per second a little bit. I believe it's 32 feet per second, force due to gravity. And then we got to times that by 1/2, so that's how we get to a negative 1/2. That's how we get to 16 there. Okay, so then we're figuring out how long will it take the flower pot to hit the ground, where the ground is 0, so plug in 0 for our height, because that's what we're trying to solve for. We're trying to solve our time, t, when it hits the ground. So we move this over, we get t by itself, subtract 64 from both sides, we get negative 64 is equal to negative 16t squared. Can't get rid of the squared yet, we need to divide by negative 16, because we're timesing by 16. And so that's 4, so 4 equals t squared. Now we can get rid of squared. How do we get rid of squared? We square root both sides, and when I square root both sides, I get a positive 2 and a negative 2. So t equals positive 2 and t equals negative 2. We're talking about time though, so we can't have a negative 2 seconds. So it will take 2 seconds to hit the ground. Okay, so now we're looking at graphing, right? To graph, the easiest way to graph, what degree is this? What is the degree of this polynomial here? Okay, go ahead and answer that. It is degree 1, right? There's 1 on that x, so it's degree 1, so it is linear. So we're looking at a line. So best thing to graph a line is we need 2 points, right? So we can make an xy table. We can pick any x we want to, right? So I can pick 0. I plug in 0 for x, so 3 times 0 plus 2 is going to be my y. 3 times 0 is 0. That's going to be my y, so 0 plus 2 is 2, so y is 2. Now I could plug in 1. Y is 3 times my x, 1 plus 2. 3 times 1 is 3. 3 plus 2 is 5, so y equals 5. So I have 2 points here. I have 0, 0. So I go, or 0, 2, so I go over 0. So that's left and right. So I don't move left and right, and then I go up 2. So that's my y-axis. Right, the second number is always my y. First number is my x. So there's the point, 0, 2, and then I can do 1, 5. So I go over 1 and go up 5. 1, 3, 4, 5. Now I have 2 points. Now I can draw my line. That's a beautiful line. Okay, that's the basic way to graph, right? Is to pick x's, plug them in for all your x's, and then solve for your y. Right, and then once you have points, you can start graphing. Right, this is in, if you remember from last year, this is in slope-intercept form. So y equals mx plus b. M is your slope, your rise over your run. Oops, 2 down there, 1 down here. So rise over run. You rise with your y's, and you run from your x's. So slope is how much I go up and down over how much I go left and right. So if it's y equals 3x plus 2, first thing I have to do is I have to graph this b, which is b is equal to my y-intercept, where it crosses the y-axis. So that'd be 0, 2. X is always 0 for your y-intercept, and your x is always 0 for your y-intercept, and whatever your b is, which would be 2, that'd be your y-intercept. That's plugging in 0 in for x. Now to find my second point, I use my slope. It's rise over run, so that means I go up or down. So m is equal to 3. I can make it a fraction. right? Because it's rise over run. So if I make this a fraction by putting 1 underneath it, I can rise 3, 1, 2, 3, and then run 1 on my x's. And there I have my second point. Now I can draw my line. Okay, so those are the two different ways you can graph linear equations. Okay, absolute value, y equals the absolute value of x. Absolute value is distance from 0. So we got our distance from 0. So when we plug in x in here, y equals absolute value of, say, -1. Again, I can make a table, right? Basically, that's what I'm doing right now. So I'm plugging in -1, and this says, this is asking, how far is -1 away from 0? So if I was on a number line, here's 0. How far is -1 away from 0? It's 1, so y equals 1. Then I can plug another number in, say 2, positive 2. So y equals absolute value of 2. This is asking how far is 2 away from 0? Well, that's 2. So my y is equal to 2. My x was 2, my y is 2. So then I can graph this. I have -1, so left on my x's, because the left is negative, and then up 1 on my y's. I plot that point, -1, 1. Now I can plot this point over 2 and up 2. So is that just a straight line? Well, it's not quite, right? Because this is almost, because remember, I can put a -1, so -1, absolute value of -1 is 1, there's distance of 1. What about absolute value of +1? Well, that is also 1. That's 1 away, right? So when I plug in a +1, I also get a 1. So it's almost two linear equations, because I can plug in a positive and get a positive, and I can plug in a negative and then it turns that to positive, right? Because it's the distance from 0. So really this is actually two equations. It is y equals x for all x's greater than 0, right? So when I plug in 2, I get 2. When I plug in 1, I get 1, because 1 is bigger than 0 and 2 is bigger than 0. And so whatever my x is, that's my y. So my x was 1, my y was 1. My x was 2, my y was 2. How about when I plugged in -1? Didn't I get a +1? So what would I have to do to this -1? Wouldn't I have to times that by a negative to get a +1? So there my equation is y equals -x. Say let's plug in -2. -2, and if I have a negative out front, right, a -x. Here's my x, and I'm taking a negative of that. So -2 would be a +2. So I got -2, comma 2. So I could graph that one too. So it's actually two lines, right? Y equals x and y equals -x, but this one's for all x's smaller than 0, so all negative ones. So what it looks like is two lines, but when I come here to 0, what's the absolute value of 0? It's still 0, right? So I get this point 0, 0. And then I come back, right? Because all my negative x's are going to change to positive. All my positives stay positive, so I go this way. But all my negatives, they switch to positive. So it's a V shape. That's absolute value. Okay, now this one, again, right, the whole point of this is basically saying that, hey, how can you graph? Well, you can just make a table. Plug in your x's. Any x's you want, right? These are going to be the easiest x's to plug in. All right, so if I plug in -1, first thing I do is square it. So that's timesing by itself, so -1 times -1 is a +1. Then I times by this 2. And 2 times 1 is 2. Okay, now let's plug in 0. Whenever you plug something in, substitute it in, put it in parentheses. 0 squared is 0. 2 times 0 is 0. So I plugged in 0, I got 0 out. Last one. Let's plug in 1. With these, you mostly always quadratics squared, right? Degree is 2. You always want to plug in, best ones to plug in usually is -1, 0, and 1, because you get just small answers. So when you graph, you can graph it pretty small. So then you don't have to graph big numbers. So plugging in 1, we square that. we get 1. 1 times 2, y equals 2. So we can graph this. -1, 2, 0, 0, and +1, 2. Now this one's not a V, it's actually a U-shaped, so it kind of goes down like that. It's actually U-shaped. It kind of looks like an absolute value. Absolute value is distance from 0, so it's always positive. But here we're squaring, which always makes something positive, right? Negative squared is a positive, and a positive squared is a positive. So it's kind of like absolute value, but it's a little curvy. It's a U-shaped instead of a V. Because here is not a line, right? Absolute value is actually two equations. It is x and minus x. So it's two lines. That's why it's a V. Here it's not two lines. It's just one equation. Okay, last one. How about a negative 2x squared? So again, let's plug in -1. So -1 squared times a -2 this time. So remember, anything negative squared is always going to be positive, and 1 times 1 is 1. Then times that by -2. And so our y is -2. Plug in a 0 for x. 0 squared is 0. 0 times the -2 is still 0, so my y is 0. So I get the point 0, 0. And then finally, plugging in a +1, and squaring that we get 1, and then 1 times the -2 is a -2. So we plugged in +1 and got a -2 as well. So notice that these are the same. We always had 0, 0. And then if we look at this one, we can see that these are also the same. Where in your equation, in this equation right here, do you see a 2? Where in this equation, where in this equation do you see a -2? And we can graph that. -1, -2, 0, 0, and 1, 2. So you notice that -2 is right there, your A, and that +2 is also your A. So a little trick that you can do is whatever your A is, right, ax squared, then if I plug in these three x's into a type of equation that looks like this, if I plug in -1, I will get an A out. If I plug in 0, I will get 0 out. And if I plug in -1, I will get an A out as well. So you can always plot those points. So you don't even have to plug those in if you have something that looks like this. Y equals ax squared. And notice that negative made that face down, right? Because I'm times it by negative. A positive in front, a +2. A +2 in front made it face up. Alright, so go ahead and write this down. A quadratic function is y equals ax squared plus bx plus c. So here's the one that I was kind of talking about. Y equals just ax squared. Here is y equals ax squared plus c. And this one is y equals ax squared plus bx plus c. And we'll take a look in the following lessons about all these different types. I showed you how you can graph this one really fast, right? It's just use your x as -1, 0, and 1, and then it'll be a, 0, a. And I'll show you how to do this one in a little bit. Okay, so copy that down, and then copy this down. The simplest form of a quadratic is f of x, function notation. F of x equals x squared, or you can write it as y equals x squared. That's called the parent function. It's the most basic quadratic function. It's always 0, 0, 1, 1, -1, 1, and we can draw our u. Boom, it's done. That's the parent function. It's always going to have these x's, the simplest x's, and our y's would be 1, 0, 1 every time for this parent function. Okay? The graph of a quadratic looks like it's called a parabola. It's a U-shape. Okay, so the graph of a parabola is in the U-shaped, and it's called a parabola. And you can fold this parabola. You can fold all quadratics. So if I have a U-shaped, I can fold those in half. This line that folds them in half is called the axis of symmetry, and it always goes through the vertex. and that vertex is, this next part, you can see the vertex is the lowest or highest point. So this axis of symmetry goes through that vertex, which is the lowest or highest point. If it's a high point, that means my graph is facing, if it's a high point, that means my graph is facing down, my U is facing down, and so that's what we call a maximum. And if I have a low point, that means my graph is facing up, my parabola is facing up, and that vertex is a minimum. So let's answer some of those questions. Okay, so go ahead and identify what the vertex here, right? Your lowest or highest point, and it's either one or the other. It can't be both. So it's either a low point or a high point, and it's located in the middle. So give me the coordinates of that point. 0, 2. Okay, go ahead and do this one. Tell me what the coordinates are, and then tell me it's a max or min. This previous one, is it a max or a min? Is it a high point or a low point? These arrows tell me it's continually going to the left and down, continually going to the right and down. So this one is a maximum because it's facing down, so that means it's going to be max. This one, what is it, max or min? Minimum or maximum, and then what are the coordinates? So I go right 1, so that's my x, 1, and then I go down 1, and since I went down, it's a negative 1. And then it is a minimum because it's a low point in the graph. Minimum is talking about my y values, right? Here's my lowest y value. My y values keep on going up, 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 and up, and up. So that's a minimum. Okay, what about here? Maximum, minimum. Go ahead and pause the video because I'm about to do it. So here I need to get to this middle. So I go over left, and since I go left, that's a negative. And I go left 1, 2, so negative 2. And here I go down, so since I go down, that's a negative. Down 1, down 2, down 3. Now is it a max or a min? Pause the video. It is facing up, so it's a minimum, right? That's a low point. Okay, now we're graphing. Like I said, these are the x's that you want to use. They're the easiest, right? And what did I say before? If you use these 3 x's on an equation that looks like y equals ax squared, is that y equals ax squared? What's your a? And all we have to do is put a here, 0 here, and a here if I use these 3 x's. If I use different x's, then it will be totally different. Okay? Okay, go ahead and answer that. So your x's will be negative 1, 1/3, 0, 0, and 1, 1/3, right? Because that's your a. Now how do you graph that? How do you graph 1/3? Well, you just count by thirds. Here's 1/3, 2/3, 3/3. So that'd be a whole, right? 3/3, 3 over 3 is 1. And so then I can go negative 1, up 1/3, 0, 0, positive 1, up 1/3. And then I can graph my parabola. All done. The domain and range. Domain is my x values. What can I plug in for x? So what can I plug in for x? Can I plug in negative 15? Can I plug in negative 15? Can I plug in negative 50? Can I plug in negative million? So on a parabola, my domain goes from negative infinity. So it's all negatives, all negatives, all negative, all negatives. Here we're at 0. Can I plug in 0 and get an answer? Yeah. Can I plug in 1? Can I plug in 2? Can I plug in 15? Can I plug in 50? Can I plug in 100? Can I plug in a million? Yes, I can plug in all positive, so it goes to positive infinity. So our domain goes from negative infinity to positive infinity. It's your choice of x values. What can I plug in for x that I get an answer? Range is your y values. Is what are my answers? What are my answers? What are my y values? What's the y value of this point? What's the y value of this point? This one, this one, this one, this one, this one, this one's on forever, right? It keeps on going up. So that means my y values keep on going up. And what's up is positive numbers, right? So it goes up to infinity. But where does it start? What's the lowest y value? Well, isn't that the y value of my vertex right here, this lowest point? What's that y value? That y value is 0. Oops. That y value is 0. So it starts, we always read our range from bottom of our graph to top. And we always read the domain from left to right. So that's why I went from negative infinity, because negative numbers are to the left, and I went through 0 and I went to positive infinity, because that's to the right. Range, I go from the bottom, which is my lowest point, which is 0, and it does hit 0, so that's why I put this bracket, because it does hit 0. I do have a y value of 0. And then it goes up and up and up and up, and it goes to positive infinity. And always infinity, we put parentheses. Okay, go ahead and graph this, and then tell me what the domain and the range is. Okay, pause the video, go ahead and try it, and then come back and watch the video, and you can pause it anytime. Okay, so again, easiest x's, because it is in the form y equals ax squared. What is your a? Because now my y's will be my a, which is negative 3. What is my always 0, and then my a again, negative 3. Now we can graph that. So negative 1, negative 3, 0, 0, positive 1, negative 3. Graph it. Now what's my domain? What can I plug in for x that I get answers out? Can I plug any number this way? Can I plug any number this way? Yep. So it's from negative infinity, because we start from left to right, to positive infinity. Okay, what's my range? Start with the lowest y value. Well, it keeps on going down, so my lowest y value is negative infinity. And then go up, because we go from bottom to top. What's my highest y value? That would be the y value of the vertex, which again is 0. And it does hit 0. I do have a y value 0, so I put that in a bracket. Okay, so now I want you to graph these three. Do these three on your own. These three functions. Graph each one of those and put them on the same exact graph. Okay, so you put them on the same exact graph. Remember, you can use these three. Use these x's, negative 1, 0, and 1. And it's going to be a, 0, a. And put those on a graph. Okay, go ahead and pause the video and try that out, and then pause it. Or pause it first and then try. Sorry. Okay, so your answer should look like this, because that negative makes it go down 1/4. Here's the parent function, right? How is that 1/4 different from this parent function? Pause the video. What is it? Wider. It's wider. What about this? So it's a negative, so it makes it face down, right? These two are positive a's, so it makes it face up. But what about that 4? What did that 4 do to the graph? How is it different than this parent function? It's narrower, right? It's skinnier. This one's wider because it's 1/4. So all my fractions, when I have fractions, the smaller the fraction, the wider it's going to be, right? So this is 1/8 is smaller than 1/4, so 1/8 would be even wider than 1/4. A positive 4 is bigger than 1/8, so it's going to be narrower. And a positive 8 is going to be narrower than the 4. 12 is going to be narrower than the 8. So the bigger the number, even if it's negative, a negative 8 will be skinnier than a positive 4. So the bigger the number, the skinnier it's going to be. The negative just makes it face down. Okay, go ahead and graph these two. Here you go. Those are your x's. What do you get? Okay, so I'll do one at a time. Pause the video after I finish one of them. So it's always my a, right? My a is negative, -1, 0, -1. Okay. Go ahead and pause the video, or you can graph that. Go ahead and graph that. So it looks like that. Go ahead and graph the second one. Pause the video. My a is 3, so 3, 0, 3. Okay, so I would put those on the same graph. So -1, 3, 0, 0. Okay, how do those compare? Which one's narrower? Which one's wider? Okay, now graph this second one. What's my a? -1/3. What does that negative do? -1/3 for 1. What does that do? That negative makes it face down, but 1/3, so I'm taking this as a positive or -1 down here, distance of 1, so cut that in thirds. When you graph it, there you go. Again, still 0, 0. How does that compare? Which one's the widest? or widest to narrowest. So which one's the widest? Put the widest first, and then followed by the less widest. So if you label these, say 1, 2, 3, how does it go? What's the widest to narrowest? Okay. So 1/3 is the widest, then followed by the negative x squared, and followed by finally the 3x squared. Okay, go ahead and answer this question. Here's your graph. Go ahead and, how is this graph different from this graph? So go ahead and graph them on the same graph, and how is it different? They almost look the same, right? They have a 2x squared. They have a 2x squared. What's the only difference? Again, you can use -1, 0, and 1. Here, I'll graph this one, y equals 2x squared. So it's going to be your a, right? Your a is 2, 0, 2. Now, this next one right here, y equals 2x squared plus 3. So isn't these the exact same, except for now I'm adding 3 to this part? Well, when I plug these x's in, won't this part right here be my a? Just like it was over here too. And then I add 3 to that. And then this would be 0, and I'm adding 3 to that. And this one would be my a, and I'm adding 3 to that. So doesn't that get me my x, -1, 0, 1? So my a is 2, 2 plus 3 is 5, so this is 5, 3, 5. Well, isn't that just taking my a and adding my c, because isn't this my c? So when you have equations like this, y equals ax squared plus c, all you have to do, you can use these same x's, -1, 0, and 1, and then it'll just be a plus c, 0 plus c, which is just c, and then a plus c every time. So how does the graph look different? Here, let's graph the one in blue. -1, 2, 0, 0, 1, 2. So here's that one, y equals 2x squared. Let's graph the one in green. -1, 5, 0, 3, and 1, 5. So how is that one different? Well, it shifted up. It went from down here at 0, 0, and it shifted up 3. It shifted up 3. Well, where do you see that 3? It's added to the x squared after. After you square x squared and times it by 2, you add 3. So it's out on the outside. Okay, go ahead and try this problem. Okay, so here, go ahead and graph this. And then graph this one. This one's the parent function, right? -1, 1, 0, 0, 1, 1. Right, it's my a. My a is 1. Here, remember, it's y equals ax squared plus c. So if my x's are -1, 0, and 1, then my y will be my a plus my c, 0 plus my c, which equals c, and a plus my c. Why did I say 3 on the top one? Not 3, sorry. C. And a plus c. Well, what is your a for this one? What is your c? So then I just use my x's, -1, 0, 1. Why? Well, my a is 1, and my c is -3. So what's 1 minus 3? That'd be -2. So -2, 0 plus c, that'd just be my c, which is -3, and then my a plus c again, which is -2. So how are the graphs related? Well, graph them. They have, what do you notice? They have the same a, 1 and 1. So that means they're going to be the same width, right? So that's how they're related, same width. All right, now we can graph them, right? And this one in red would be -2, 1, -2, 0, -3, and 1, -2. So how are they the same? Well, they got the same width, right? Because they have the same a. They both face up. Both have same width and face up. right? The only difference is the red one's down 3. That's because my c was negative 3. So it's down 3. Okay, here we go. Here's a word problem. Again, it's like kind of like your warm-up, right? So they give us the equation for height, right? So here's the flower pot, basically, right? Fallen from 20 feet. We have our equation for a height. We want to find out, okay, what is the graph of this quadratic function? So we're just asked to graph this. Well, isn't that just y equals ax squared plus c? So can I just plug in -1, 0, and 1? And when I get my a plus my c, so what's your a? What's your c? A is -16, c is 20, so can I add those? What's 20 minus 16? Isn't that 4? What's 0 plus my c? So what's my c? It's 20, and then 4. So then can we graph those? So -1, 4. Well, let's count by 4s actually. 4, 8, 12, 16, 20. So we're counting by 4, so this is 20 up here. So 1, 4. Well, if we're counting by 4s, we should probably count by 4s on the x-axis too. So this is probably 1 down here. So 1, 4, 1, 4, 0, 20. So our graph probably looks something like this. Really narrow, right? It's negative a, so that's why its face is down, and 16 is a big number, so that's why it's really narrow, right? Okay, so there's the graph. So there's that part. Now, what about what time the acorn hits the ground? Well, what's the height, h, when it hits the ground? Wouldn't that be 0? So 0 equals -16t squared plus 20. So remember how we solved this in the first warm-up? You can go back if you need to. Watch that part, and then come back and finish this. So we subtract 20 from both sides. We divide by -16. All right, and negative divided by negative is a positive, and then 20 divided by 16 is 1.25, and since this is an application problem, we can go ahead and leave it as 1.25. Then how do we get rid of squared? We square root, and when we square root we get a positive and a negative, but I don't care about the negative, right, because we're talking about time, and time's always positive. So I need to take the square root of 1.25, and I get approximately 1.12. So that's how much time it takes to hit the ground. Okay, go ahead and try this problem on your own. It's the exact same as the other one. So if you have to rewind it, and use that other example. So we're going to draw the graph of this, and then we're going to go put in 0 for h, and solve for t. Okay, and you can use decimals. Alright, so here's the graph. This time it's 70, right? So maybe 10s, 10, 20, 40, 10, 20, 30, 40, 50, 60, 70. And so this would be 10, so 1 would be like right in here, a -1. So that'd be -10, that's 10, that's 70. And then a +1 would be right there. So it's your x's, right? Easiest x's. Then your y's is going to be your a plus c, your c, and a plus c. So what's your a? What's your c? -16 and 70. If we subtract those, 70 minus 16, right, 64, or 54, sorry. So those are my x's. This is 54. This would be 54. My c is 70. So here 10, 20, 30, 40, 50, 54, maybe somewhere right here. So at -1, 54, +1, 54, and 70, 0, 70. And draw parabolas. So there's our graph. Now we set it equal to 0. We can solve for x by subtracting 70 from both sides, because we're adding 70, so we need to move that. So we do the opposite, get rid of it. We have -70 equals 70 minus 16t squared divided by -16. Negative divided by negative is a positive. 70 divided by 16 equals 4.375 equals t squared. How do we get rid of squared? Square root. We don't care about the negative, right? We just care about the positive, so I'm going to square root that answer. and we get 2.09. So t is equal to 2.09, so it's approximately 2 seconds, 2.09 seconds. All right, there you go.